So we are going to find out the radius of a charged particle in a magnetic field, especially when the charged particle enters at 90 degree to the magnetic field for different cases. That means if you know the momentum of the charged particle, what is the radius? If you know the kinetic energy, what is the radius? And if you know the volume, what is the radius? Most of the CBSE and NEET questions are based on that. Suppose you know momentum is mv. If you know that kinetic energy is half mv square, just multiply and divide by m. It is m square v square, that is square of the momentum, by 2m. So it is p square divided by 2m is actually the kinetic energy. Okay, and v, the potential difference with which you accelerate the charged particle. We know that work done per unit charge is equal to potential difference. The work done is converted into kinetic energy. So the kinetic energy per unit charge equal to kinetic energy acquired per unit charge is equal to V. That means kinetic energy is equal to charge into V. These are three relations you must know. The kinetic energy acquired is charge into potential difference, and the kinetic energy is square of the momentum by 2m, or in other words, P square equal to 2m into kinetic energy, or P is equal to root over 2m into kinetic energy. Whereas kinetic energy can be written as q into v. So momentum can also be written as 2m instead of kinetic energy qv. So the important results here are momentum is 2m into kinetic energy. Momentum is also equal to root over 2m into charge into potential difference across which the charge is accelerated. So let us try to find out the radius of the charged particle. You know that when a charged particle enters into magnetic, assume that the magnetic field exists in this region fully. In this region, fully it is existing and it is into the paper. So when the charged particle enters, the charged particle moves in a circle. And here we are going to find out the radius of the charged particle. When a charged particle enters, it moves in a circle, means the charged particle is experiencing centripetal force. So the centripetal force is mass of the charged particle v square divided by radius of the charged particle. So this charged particle experience centripetal force due to magnetic force. So this centripetal force is provided by the magnetic Lorentz force, which we write it as q into v cross b. This q into v cross b is written as q v b sine theta n cap. So if you are taking only the scalar or the magnitude of this, b qv sine theta, because here we are assuming charged particle enters at 90 degrees, so sine 90 degrees 1. So the force is bqv. This bqv is the force providing this centripetal force, hence we can equate these two. So bqv equal to m v square by r. This v and square will be cancelled, so r can be written here, so which means that r is equal to mv by bq. So the radius of a charged particle in a magnetic field is given by the relation r is equal to mv by bq. Here comes our important points. So the radius of a charged particle is mv by bq. Also, this mv is nothing but momentum p divided by bq. So as we discussed here, momentum can be written as 2m into root over kinetic energy, root over 2m into kinetic energy by b into q. Also, this momentum can also be written as root over 2m into q into v, because kinetic energy can be written as what? qv. Kinetic energy is qv. So we are writing root over 2m qv divided by bq. So there is no square root over this bq, but there is q over there. So let us try to take the full square root. So the numerator stays as it is, but denominator bq, when that goes into the square root, it becomes b square q square. So when you cancel q and square here, q stays. So that means the radius of the charged particle here, I will write the important parts here. So the radius of the charged particle is square root of 2mv by b square q. So the important results here, I will just square it up. One is radius is this, r is equal to mv by bq, or r is equal to root over 2mk by bq. Here the kinetic energy is known, and if charge is known, either you can use this or you better use this. So if you know the potential difference with which the particle is accelerated, you can take this. So v, and this v is velocity. Actually this v is velocity, and this v is potential difference across which particle is accelerated into the magnetic field, and this is the kinetic energy of the particle. So you remember this formula, and how to apply this formula in the following problems I will explain.